Welcome to Learner's Prep. In this session, we will learn the concept of LCM and HCF. This is the first session in this concept. First of all, let us see what are the important points for this topic. Common factor. A common factor of two or more numbers is a number that divides each of them exactly. So let us see an example. Factors of 12. 1, 2, 3, 4, 6 and 12. And similarly, factors of 18. 1, 2, 3, 6, 9 and 18. So what are the common factors? 1 is a common factor, 2, 3 and 6. So these are the factors of both 12 and 18. So they are called common factors. Next, highest common factor. So in the common factors, whatever is highest, that is the highest common factor, and its abbreviation is HCF. So the highest common factor of two or more numbers is the greatest number that divides each of them exactly. So that is a definition. And it is also called GCD, greatest common divisor, or GCM, greatest common measure. So again, example, HCF of 12 and 18. So what were the common factors? 1, 2, 3 and 6. So since 6 is the highest, that is the HCF of 12 and 18. Methods of finding the HCF. So first method is prime factorization method. So what are the steps here? Express each number as a product of prime factors. Second step, identify the common prime factors. So multiply the common prime factors with the smallest powers. So that gives the HCF of the numbers. So let us see an example here. HCF of 36 and 48. So what is the prime factorization of HCF 36? So 2 square into 3 square. So how do we find the prime factorization? 36. It is divisible by 2 18 times, and then again divisible by 2 9 times, divisible by 3 3 times. So 2 multiplied 2 times and 3 multiplied 2 times. So this is the prime factorization. If you write in exponential form, it is 2 square into 3 square. So this is the prime factorization of 36. Similarly, for 48 also, it is 16 times 3. 16 is 2 to the power of 4. Now, common factors with smallest powers. So 2 is common in both. Its smallest power is 2. So we write 2 square. Similarly, 3 is also common in both. Its smallest power is 1. So we take 3. So 2 square into 3 is 4 into 3, 12. So that is a HCF of 36 and 48. So 12 divides both 36 and 48, and that is the highest common factor. So next we have the division method. So division method or Euclidean method. So divide the larger number by the smaller number. Divide the divisor by the remainder. So continue until the remainder becomes 0. The last divisor is the HCF. So let us see an example. HCF of 84 and 30. So when 84 is divided by 30, so it is divisible 2 times. So 32 is 60. So what is the remainder? 24. So 30 should be again divided by the remainder 24. So 24 divides 1 time. 30 minus 24 is 6. That is the remainder. So again divide 24 with 6. So it is it divides 4 times. 6 4s 24. So the remainder is 0 here. So the last divisor 6 is the HCF. So this is the division method of finding the HCF. Next, common multiple. A common multiple of two or more numbers is a number that is exactly divisible by each of them. So, for example, multiples of 4, 8, 12, 16, 20, 24, etc. So, there are infinite number of multiples. Similarly, multiples of 6, 12, 18, 24 and so on. So, what are common in both? 12 is common, 24 is common and so on. So, these are the common multiples for both 4 and 6. Least common multiple. So, among the common multiples, whichever is the least, that is the least common multiple. Its abbreviation is LCM. So, the least common multiple of two or more numbers is the smallest number exactly divisible by each of them. So, for example, again let us take 12 and 18. Multiples of 12, 12, 24, 36 and 48. Multiples of 18, 18, 36, 54 and so on. So, least common multiple is 36. So, that is the LCM of 12 and 18. So, what are the methods of finding the LCM? So, here also we have prime factorization method. So, what are the steps involved here? Resolve each number into prime factors. Take all prime factors with highest powers. Multiply them. So, these are the three steps in finding the LCM. So, let us see an example, LCM of 24 and 36. So, 24, what are the prime factors? 8 into 3. So, 8 is 2 cube into 3. 36 is 4 nines. 4 is 2 square, 9 is 3 square. So, these are the prime factorizations. So, here 2 and 3, we should take the highest powers. So, the highest power of 2 is 3. So, take 2 cube. Similarly, highest power of 3 is 2. So, take 3 square. 2 cube into 3 square, that is 8 into 9 is 72. So, the LCM of 24 and 36 is 72. So, that is the least number divisible by both 24 and 36. So, there is another method, division method. So, the steps involved are write the numbers in a row, divide the prime numbers, divide by prime numbers that divide at least one number. Continue until all numbers become 1. Product of all the divisors gives the LCM. Example, so LCM of 12, 18 and 30. So, let us start dividing with the smallest prime number 2. So, if we divide 12, 18 and 30 by 2, 12 is divisible 6 times, 18 divisible by 2 9 times and 30 is divisible by 2 15 times. So, in this way you should go on dividing till you get all ones. So, what are all the divisors here? 2, 2, 3, 3 and 5. So, if you multiply all of them, you will get 180. So, that is the LCM of 12, 18 and 30. So, this is the division method of finding the LCM. So, what are the important formulas in this concept? So, for any two positive integers, the product of HCF and LCM is equal to product of the numbers. So, product of LCF and LCM and product of the numbers is equal. So, for example, LCM of 18 and 24, find the LCM of 18 and 24 if HCF is 6. So, the two numbers are 18 and 24, their HCF is 6. What is the LCM? So, if you want to find out the LCM, find the product of the numbers and divide with 6. So, 18 and 24 multiply and divide with 6. So, that gives you 72 as the LCM. So, using the above formula, we can find out of these 4, if any one is missing, that can be found out using this formula. Now, let us solve some practice questions based on these concepts. Question number 1. So, as far as possible, we'll try to use the short methods to solve the questions. What is the LCM of 14, 21 and 25? 14. So, what are the prime factors of 14? 2 and 7. Prime factorization is 2 into 7. Similarly, 21, 3 into 7. 25 is 5 into 5. So, that means the LCM must be divisible by 2, 3, 5 and 7. It should be divisible by all the numbers. So, then only that will be the LCM. So, now let us check all the numbers. Options, let us see. If you observe all these options, they are all divisible by 5. So, since all of them are divisible by 5, you can ignore 5. Now, let us check with 2. All the numbers are ending with 0 except C. So, this C is not the answer. This cannot be the LCM because it is not divisible by 2. C cannot be the answer. We checked with 2. Next, we'll check with 3. So, what is the divisibility rule of 3? Sum of the numbers must be divisible by 3. And similarly, we have to check with 7 also. So, for 7, let us check first of all. So, these 3 numbers, 1050, that is divisible by 7. So, how many times? It is 15 times, 150 times, 100 times and 50 times. So, all these 3 numbers are divisible by 7. So, you can ignore 7. Now, let us check with 3. So, out of these 3 numbers, option D not divisible by 3, option B not divisible by 3, option A is divisible by 3 because sum of the digits is 6. So, 6 is divisible by 3. So, it is divisible by 3. So, we should check with the divisibility rules. So, option A is divisible by all the 3 numbers, all the 4 numbers 2, 3, 5 and 7. So, option A is the right answer. Or we can also use any one of the methods which we have seen in the concept explanations. Question number 2. Find the LCM of 135 and 180. Here also let us see 135, 180. So, if the numbers are big, instead of going for prime factorization, we can use any one of the methods of division or prime factorization method. So, 135. So, this is divisible by 5. How many times? 5 2s, 5 7s. And 27 is nothing but 5 into 3 cube. Similarly, 180 is divisible by say 2 into 90. 90 is again 2 into 45. 45 is nothing but 9 into 5. 2 into 2, 9 is 3 square into 5. 9 5s. Now, let us find the LCM by taking the highest powers of all the numbers. So, first of all 2, the highest power is 2 because 2 is 2 times. Similarly, 3 is 3 times the highest power and 5 is only 1 time. So, if you multiply them, 4 into 27 into 5. So, 5 4s 20, 27 into 20 is 540. So the LCM is 540. So if the numbers are bigger, you can directly go for any one of the methods which we have discussed in the beginning. So option A is the right answer. Question number 3. What is the smallest 5-digit number that is exactly divisible by 48, 60, 72 and 90? So first of all, we have to find out the LCM. LCM of these numbers: 48, 60, 72 and 90. So 48, what is the LCM? So we'll start writing from the beginning. 48, 60, 72 and 90. 48 is 16 threes. 16 is 2 power 4. 16 threes. 60 is 15 fours. 4 into 15. 15 is 3 into 5. Next 72. 72 is 36 twos. 36 twos or 8 nines. 8, 9. 8 is 2 cube, 9 is 3 square. Then again 90. 9 into 10. 9 is 3 square. 10 is 2 into 5. So let us find the LCM here. So 2, first of all, let us start with 2. The highest power is 4. 3, highest power is 2. 5, highest power is 1. This is 16 into 9 into 5. So that is a 16 nines, 144 multiplied by 5. That is 5 fours 20. Again 5 fours 20 plus 2 22. 5 ones 5 plus 2 7. 720 is the LCM of these numbers. So the question is, what is the smallest 5-digit number that is exactly divisible by these numbers? So as far as our knowledge, what is the smallest 5-digit number? So smallest 5-digit number is according to us is 1 followed by 4 zeros. 10,000. This is the smallest 5-digit number. So let us divide 10,000 with 720. 10,000 let us divide with 720. So 1 time 720, subtract 0, 8, 2, 280. So carry one more 0, 2800. So let us see 4 times. 4 zeros, 4 twos 8, 4 sevens 28. So 2800, if you subtract, you will get minus 80. So that means if you add 80 to 10,000, that becomes divisible by 720. So 10,000 is the smallest 5-digit number. If you add 80, it becomes 10,080. So this is the smallest 5-digit number which is divisible by these 4 numbers: 48, 60, 72 and 90. So the answer is option A is the correct answer. Question number 4. What is the smallest perfect square number that is exactly divisible by 45, 75, 90 and 120? So let us find out the LCM of all these numbers. 45 and 75, 90 and 120. So 45 is 9 into 5. 9 into 5 is 3 square into 5. And 15 into 5. So that is 25 into 3. 25 is 5 square. 90 is 9 into 10. 9 is 3 square. Into 10 is 2 into 5. 120 is 24 into 5. 24 is 8 threes. 24 into 5. Now let us find the LCM. LCM is the highest powers of 2, 3 and 5. 2 highest power is 3 and 3 highest power is 2 and 5 highest power is 2. So this is 8, 9 and 25. So 25 8's 200. 200 into 9 is 1800. So 1800 is LCM of all these numbers. So if you notice here the prime factorization here, the powers of all these numbers in 2 cube and 3 square and 5 square. The powers of all these numbers, if you notice, 5 the power is 2, which is an even number. 3 the power is 2, which is an even number. Whereas 2 the power is 3, which is an odd number. So the powers of all the numbers must be even, then only it becomes a perfect square. So to make the number as a perfect square, 2 power should become even. So it should be multiplied by 1 more 2. So if you multiply by 1 more 2, then it becomes 2 to the power of 4 into 3 square into 5 square. So that means that is 1800 into 2, that is 3600. So 3600 is a perfect square, smallest perfect square which is divisible by 45, 75, 90 and 120. So if you multiply with 2 with the LCM of all these numbers, then you will get the smallest perfect square among these numbers. C is the correct answer. Question number 5. The LCM of two numbers is 2268 and their HCF is 18. If one of the numbers is 126, then the other number is what? So we have seen in the examples. So to find out the other number, so the other number to find out product of LCM and HCF must be divided by the given number. One of the numbers is 126. So if you divide the product of LCM and HCF with one of the numbers, you will get the other number. So simplify this, 9 2's, 9 1's and 9 4's. So this is 2 1's and 2 7's. Then again 7 3's, 21, 16, 7 2's, 14, 2 remains 28, 7 4's, 28. So what is remaining? 324. So other number is 324. So the correct answer is option A is the correct answer. Question number 6. The HCF of two numbers is 18 and their LCM is 154 times their HCF. If one of the numbers lies between 250 and 350, then the sum of the digits of the other number is what? So here HCF is given and LCM is 154 times of HCF. And the one of the numbers is between 250 and 350. So if HCF is 18, so 18 is common for both the numbers. So let the numbers be 18x and 18y. So let the numbers be 18x and 18y. Because 18 is a HCF. So 18 lies in both of the numbers. X and y are co-primes. So they don't have any HCF. Their HCF is 1. Because already the common factors are taken out and their product is 18. So here 18x into 18y, product of the numbers, is equal to HCF into LCM. So HCF is 18 and LCM is 154 times of HCF. 154 times of HCF. This is the equation. So let us solve this one and find the values of x and y. So 18 cancels both sides. So what is remaining here? X into y is equal to 154. So the product of x and y is 154. So we should find the factors of 154 such that they are co-primes. So 154, if you take the prime factors, the factors 2 into 77. So 2 and 77 and not divisible by 3, not divisible by 4, not divisible by 5, and it is divisible by say 11. 11 into 14. 11 into 14. So if you consider 2 and 77, 2 is a very small number and 77 is a very big number. So both the numbers, if you multiply with 18, they cannot lie between 250 and 350. None of them will lie between 250 and 350. So let us check with 11 and 14. So let x is equal to 11 and y is equal to 14. So what are the numbers? 18 into 11 is one number, that is 198, and other number is 18 into 14. So that is 14 8s 72, 7 carry. 14 8s is 112, 11 carry. So 14 1s 14 plus 11, 25. 252 is one number, 198 is the other number. So one of the number is between 250 and 350. So according to the question, we got one number. So what is the other number? 198 is the other number. So the question is the sum of the digits of this number. So sum of the digits of 198. Sum of the digits is 1 plus 9 plus 8. That is 18. 18 is the sum of the digits. The correct answer is option C is the correct answer. Question number 7. What is the smallest number between 600 and 700 that is exactly divisible by 9, 12 and 18? So here also we have to find out LCM of these three numbers. So LCM of 9, 12 and 18. So 9 is 3 square, 12 is 4 threes, 18 is 9 twos. So what is the LCM? LCM is the highest powers 2, highest power 2, 3, highest power is 2. So that is 4 into 9, 36. 36 is the LCM of 9, 12 and 18. So we have to find out the smallest number between 600 and 700, which is divisible by 36. So which is immediately after 600. So that means let us divide 600 with 36. 600 let us divide with 36. So how much is falling short? We should find out. So 36 once 36. So by subtracting you will get 4 here, 2 here, carry 1 0. Now let us see with 36 sevens, 7 6 42, 7 3 is 21 plus 4, 252. So 7 times 7 6 42, 7 3 is 21 plus 4, 25. So if you subtract here, you will get minus 12. Minus 12. So that means we need to add more 12 to 600, then it is divisible by 36 17 times. So it becomes 612. So 600, if you add 12, it becomes 612, then it will be divisible by 36 17 times. So 612 is the correct answer. That is the smallest number between 600 and 700, which is divisible by all these three numbers. Option A is the correct answer. Question number 8. The LCM of two numbers x and y is 120 times their HCF. If their HCF is 6 and the difference between the numbers is 114, then find the value of x plus y. So HCF is 6. So then we should assume the numbers. Let the numbers be 6x and 6y. 6x and 6y. So product of the numbers is equal to product of the LCM and HCF. 6 is the HCF. LCM is 120 times of their HCF. So 120 times of HCF. 6 into 120. So let us simplify. 6 gets cancelled both sides. So what is remaining here? X into y is equal to 120. Now the difference between the numbers is 114. So x and y are co-prime numbers. So let us write down the prime factors of 120 which are co-primes. So 2 into 60, they are not co-primes. 3 into 40, they are co-primes. 4 into 30, they are not co-primes. 5 into 24, they are co-primes. 6 into 20, they are co-primes. and 8 into 15, they are co-primes. 10 into 12, they are co-primes. So here we have 4 non-co-primes and 3 co-primes. So let us see whichever is appropriate among all this. So 3 and 40, 3 is very small and 40 is very big. So if you consider them, the difference cannot be 114. So let us try 5 and 24. 6 into 5 and 6 into 24. 6 into 5. 6x and 6y. This is 30 and 6 into 24. That is 144. So according to the question, the difference must be 114. So what is the difference here? 144 minus 30. 114 is the difference. So the numbers are 30 and 144. So the numbers are 30 and 144. So the question is we need to find out their sum, x plus y. So we have to find out their sum. So what is the sum of the numbers here? 30 plus 144. That is 174. This is the sum of the numbers. 144 plus 30, 174 is the sum of the numbers. So option D is the correct answer. Or we can also directly use x into y is equal to 6 into 120. So instead of taking 6x and 6y, we can also take in this way as well. Directly you can assume the numbers as x and y. So their product is x into y is equal to 6 into 120. So using this method also we can directly find out the numbers. Question number 9. The sum of two positive numbers is 98. Their HCF is 7 and their LCM is 168. Find the sum of the reciprocals of the two numbers. The sum of two positive numbers is 98. So let us assume the numbers as x and y. X plus y is equals to 98. Their HCF is 7 and LCM is 168. So product of the numbers x into y is equal to product of HCF and LCM. X into y is equal to 7 into 168. Find the sum of the reciprocals. So he is asking us to find out the sum of the reciprocals. This is x into y, xy is equal to 7 into 168. So he is asking us to find out sum of the reciprocals of the numbers 1 by x plus 1 by y. So what is the LCM here? xy is the LCM. So xy is divisible by x y times and xy is divisible by y x times. So the numerator is x plus y, which is equal to 98. The denominator is xy, which is equal to 7 into 168. So if you simplify, 7 ones, 7 fours. Then again 14 ones, 14 twos. So what is remaining here? 1 by 12. The numerator 1 is left out, denominator 12 is left out. So The sum of the reciprocals is 1 by 12. This is the answer. Option D is the correct answer. Question number 10. Let x be the smallest number which, when added to 1500, makes the resulting number divisible by 8, 12, 15 and 20. Find the sum of the digits of x. Similar question, we should find the LCM of these four numbers: 8, 12, 15 and 20. So what is the prime factorization? 2 cube. This is 2 square into 3. This is 3 into 5. This is 2 square into 5. 4 5s. So the LCM is 2 highest power 3, 3 highest power 1, 5 highest power 1. So this is 8 into 3 into 5. 120. LCM is 120. Now we should find out the smallest number which, when added to 1500, it is divisible by all LCM of all these numbers. So we should divide 1500 with 120, and how much is falling short we should find out. 120 once 120. So by subtracting we will get 30. So carry one more 0. So 300. So the nearest multiple of 120 is 123s. 123s is 360. So by subtracting you will get minus 60. So if you add 60 to 1500, so it is divisible by 120 13 times. So that means 1500 plus 60. So if you add 60, then it will be divisible by 120. So the smallest number that should be added to 1500 is 60. So 60 should be added. So the question is, what is the sum of the digits of 60? Sum of the digits. 6 plus 0 is 6. The answer is 6. Sum of the digits is 6. Answer is option B. Question number 11. Find the LCM of the following numbers. So here the numbers are directly given in the exponential form, prime factorization form. So we should take the highest powers of all the numbers. So if you notice, 2 highest power is 5. Next 3 highest power is 4. Next we have 5 highest power as 3. Next is 7, only 1, and 11 is only 1. So this is a LCM of all the given numbers. So what is the correct option here? 2 power 5, 3 power 4, 5 cube, 7 into 11. Option A is the correct answer. Direct question. Question number 12. So again here also we have all the powers. We should take the highest power of the variables and LCM of the coefficients. So what are the coefficients here? 6, 12 and 18. So for 6 and 12, 12 is a multiple of 6. So we can ignore 6. 6 can be ignored because 12 is a multiple of 6. So 12, 4 3s, 4 3s. This is 9 2s, 9 2s. So what is the LCM? 2 highest power 2, 3 highest power 2. 4 into 9, 36. The LCM is 36 for the coefficients, and the highest powers of x, highest power 3, and y highest power is 3, and z highest power is 2. 3, 3, 2. Again, option A is the correct answer. Question number 13. So, what is the LCM of 14 root 2, 18 root 8 and 8 root 18? So, let us write down the prime factors. 14 root 2 is 2 into 7 into root 2. Next, 18 root 8. So, 18 root 8. So, root 8 can be written as 2 root 2, because of 8 is 4 root 2. Sorry, 8 is 4 into 2. When 4 comes out, it becomes 2. That is 2 root 2. So, 18 is 9 twos. 9 twos. There are 2 twos. Next is 8 root 18. So, 18 is nothing but 9 into 2. 9 when it comes out, it becomes 3. So, that is 8 into 3 into root 2. So, this is 2 cube into 3 into root 2. So, now, so let us write down all the highest powers. 2 highest power is 3. 3 highest power is 2. And we have 1 7 and we have root 2. So, 2 power 3, 3 square, 7 into root 2. Option A is the correct answer. Question number 14. Find the smallest number which when divided by 14, 18 and 24 leaves a remainder of 5 in each case. So, here also we should find out the LCM of all these three numbers first of all. So, for 14, 18 and 24. 14 it is 2 times 7. This is 9 twos. So, this is 6 fours or 8 threes. 8 threes. So, what is the LCM? The highest powers we should take. 2 highest power 3, 3 highest power 2 and 7. That is 8 into 9 into 7. So, 8 9s 72 into 7. 7 2s 14. 1 carry, 7 7s 49 plus 1 50. 504. So, this is a LCM of all these three numbers. So, when you divide 504 with any one of these three numbers, the remainder will be 0. But we should get remainder 5. So, that means we should add 5 to this number. 504 plus 5. So, if you add 5, so when you divide with any one of these numbers, 5 will become the remainder. So, whatever the remainder you want, that should be added here. So, 509. So, this is the correct answer, 509. Option B is the correct answer. Question number 15. What is the smallest 4-digit number that is exactly divisible by 18, 20, 24 and 30? So, find the LCM again. 18, 20, 24 and 30. So, 18 is 9 twos. 20 is 4 fives. 24 is 8 threes, 30 is 6 fives. So what is the LCM here? Highest powers 2, highest power 3, 3 highest power 2, and we have 5. So that is 8 into 9 into 5. 8 into 9, 72 times 5, which is equal to 360. Now the smallest 4-digit number. Smallest 4-digit number. What is the smallest 4-digit number? 1 followed by 3 zeros. That is 1000. So what is the next 4-digit number which is divisible by 360? So we should divide and find how much is falling short. 1000 divided with 360. So if you divide 3 times, this is 3 zeros, 3 6 18, 1 carry, 3 3 is 9 plus 1 10. So 1080, if you subtract minus 80 is falling short. 80 is falling short. So that means if you add 80 to 1000, 1080, it will be divisible by 363 times. 1000 plus 80, that becomes 1080. So 1080 is the smallest number, 4-digit number, which is divisible by all the 4 numbers, 18, 20, 24 and 30. So option A is the correct answer. So these are the problems based on the concept of LCM and HCF. We will solve some more problems in the next session. We will meet in the next session and solve some more problems based on this concept of LCM and HCF. Thank you.